My name is Duarte, and I'm a research assistant in the Institute of Telecommunications in Portugal. And we have this Aveiro Living Lab that I will present to you and our research. To start, I will present the Vision Lab. What is the vision? What about I think that we are doing wrong in smart cities? After that, I will present the research domains that we work and the technologies, and also the part of the network that we work, vehicular communications, 5G, and also the part of the orchestration, the service and use cases, and my final remarks. Regarding the team is the Network Applications and Protocols group. We work specific more in network applications and protocols. But we have all of these use cases regarding mobility, drones and swarms, autonomous driving, computer vision. In terms of networks, we work in the 5G, vehicular networks, local area networks. More regarding these topics of software deterministic networks, software-defined networks, multi-access edge computing, vehicular perception that goes connected with autonomous driving, and of course everything regarding with real-time. More regarding the data platform that we have on the city, the management platforms, of course also these new topics of digital twins, and also federated learning, and starting here with the Eclipse Foundation, also the software-defined vehicle part that we try to bring more this part of determinism of time-sensitive networks that we work to the software-defined vehicle part. Regarding the Aveiro Living Lab, one of the points that I have here is that I think that we think in the smart cities as software developers, and this is the problem for me of the smart cities. I don't know how many smart cities do we currently have in Europe, but I think that part of the solutions that we have on one smart city we cannot push to the others. I think that this is the problem. We don't have this kind of marketplace, that we have some kind of application that connects with the hardware of the other cities. And for me, I think that is the main problem. I put here an example of the Xionggang smart city in China, that they are building the city. At the same time, they are syncing in the infrastructure of the city in terms of networks and sensing. My point is that one. I think that the smart cities we should think the smart cities as we think in the energy infrastructure, telecommunication infrastructure. We need to have a network infrastructure for the city and the sensing part. We need to think on that for the city. Try to some kind standardize that part. And after that could build some kind of ecosystem, data ecosystem, service ecosystem, these kind of things. Imagine that you are a company that have some kind of service that analyzes the feed of the video camera. You don't need to deploy another camera. You have already one there, but you cannot do that these days. You only connect like NGSCI data, these kind of things, but I think that this will not work, and I think that is not working now. And based on that, we have this kind of approach. We initially fund this network, but after that, we also receive some money to invest in the infrastructure by Urban Innovation Action, also together with the City Council of Aveiro. What we have is, we have 44 processing and sensing nodes through 16 kilometers of fiber deployed in the city. We manage all of this network. We also have private 5G networks working, only 5 points, but we have there. And also, for us, we think that this is the way that we can reduce the CapEx and OpEx. Because if you are a company and if you want to use our sensors, you can deploy your service in our smart city, okay? And you cannot need to deploy additional devices for that. You can access the devices directly and not only by the software part. And this is what we are proposing. Also, we also manage all of the infrastructure in a cloud-like platform model, okay, with Kubernetes and other tools. And of course, as researchers, this is a little bit different, but we maintain all of this infrastructure by ourselves. This is the example of the smart lampposts that we have. On the top of the smart lampposts, we have vehicular communications, Wi-Fi, and also the private 5G. We are also moving the things that we have on the top part of the things regarding the processor to the middle of the smart lamppost because it's easy to make some maintenance. As you can see, to make some maintenance, we need to stop the roads, call the police, and also contract these kind of companies. Also, in the post we have millimeter wave, video cameras, and also radar and LiDAR to measure the mobility of the city and also to collect some counts, for instance, with video cameras. In terms of research domains and technologies that we use, this is basically more the network part of the city, okay? And I put here some open source projects that we use, from 5G, Open5GS, Free5G, Camalio, Camara. Here we use software-defined network to manage all of the network of the city. For instance, all of the vehicular communications are managed by also software-defined networks. We did a different approach with Open vSwitch to implement the V2V. Also, we work with time-sensitive networking and the project of Open Wi-Fi to do some kind of determinism in Wi-Fi. Also, in the part of the 5G, we used OCDU now, Open Air Interface, and these kind of projects with software-defined radios. Also, for the vehicular communications, we used the 82.11p. And for orchestration in the service, we are using Kubernetes, Docker, and Proxmox. I will not specify too much here, but as you can understand, we have the fiber connected with that part of the city cluster where we have all of the smart lampposts. This is one of the examples of ONOS. I don't know if every one of you work with software-defined networks, but this is the representation of the city. I don't have here, but sometimes you will see some vehicles connecting here and connect by itself the two with V2V. In terms of orchestration and data platform, we also use some of these tools. We have some kind of collection between real-time data and non-real-time data that pass by Kafka. After that, we represent everything. We process everything in some kind of microservice architecture. And after that, we use this model of Feaware, the Orion, to store everything, and also in the MongoDB. This is part of the things that we have. We also monitoring with Grafana and Prometheus. Also, we work with autonomous mobility, waves and rovers. Okay, this is one example of the PixKit that we use to work with AutoWare, and this is the architecture that we use. Here we have the onboard units that connect with one of the projects that we extend that is called Vanessa for ETS G5 message. We implement all of this message, and we also are part of the AutoWare Foundation, contributing with the V2X stack in that project. As you can see, we also work with the PixSoC in the rovers and in the drones. Also, the use case that we usually do in the drones is to extend the network, like the 5G network, try to extend and to give more cover, but also in the part of perception. In terms of service and use cases, this is an example of one of the French companies, I think Navia, that has this kind of autonomous bus. The autonomous bus communicate with ETS G5, and we create some kind of virtual semaphore that when we, with the camera, detect the cyclist, we send a message to the Navia bus, and the Navia bus will stop. This is one of the examples with integration of our platform. At the right is only the vision that you can see with the autonomous vehicle. Okay, and based on that, we are using also that autonomous vehicle to work more in the software-defined vehicle part. More things.
The bicycle or also?
We also have works in the bicycle part. Okay. This is the platform that we implement. This is more for, because we don't have any product with that, and we are from research perspective. But this is the city. As you can see, you have the yellow ones is everything that you are detecting with video cameras. Okay. For instance, if you have a Volkswagen-based automotive and if you enter in the city, we will see your car, your velocity, because the Volkswagens communicate with ETS G5. I don't know what is the registration of the car. I don't know all of that specifics, but I will see the velocity, and I will use the velocity of the car to mobility perspective. For instance, that road with that car, I will store that information. These are the smart lampposts. We can do different use cases, but this is the vision of real time that we can see. With cameras, we can do a lot of things. This is an example what we can do with computer vision, the smart parking at the top. Here, some kind of metrics regarding the smart crosswalk. How many people is waiting here? What is the time? How much time people spend here? And the proximity of the cars there to the people. That crosswalk is very problematic. It's near the university, and a lot of people is always passing there. And also you can use for tourism. In terms of monitoring platform, we collect a lot of data, and sometimes we have a lot of problems because of that, because we generate a lot of data. I put here, we use Grafana and Prometheus to do that regarding, we can see the message that we are using, transferring in the MQTT and in the brokers, also in the Kafka. Sometimes the Kafka, imagine that some student do some kind of crazy thing and put a lot of message in Kafka, we can understand that. Sometimes this happen. More things. This is the Orion perspective, and I also have here the Mongo perspective. We also store a lot of documents in Mongo. Mongo is our database that we are using. And as you can see, we have a cluster of FireWire Orion service, and more things here, and you can see we are measuring all of the performance. This is some examples from some verticals that we have on the city. This is the smart parking part. That one is the mobility perspective. As you can see, we have all of the roads. We could put the segments of the road and associate some of the metrics there also. This is one of the examples what we can do with the smart crosswalks. This is a normal day. All of the people at 9 go to the school, and that one is a university night event. As you can see, at 6 hours, all of the people are going to home. Regarding the integration with AI, we also, in the last year, integrate this agent. We can make some questions to the database, and the agent will answer to that. And that's it. My main points here is that we need to think in smart cities in a different perspective, not only in the software perspective. Guys, I think that we need to create this standard, like we create in the smartphones. We can have different brands of hardware, okay? But all of the applications are the same. I think that we need to do that to reduce this CapEx and OpEx. For me, it not makes sense to have two cameras doing the same in the same place, collecting the same data, okay? And that's it. I think that I put this message here that I think that we also can build smart cities with open source because part of the software are open source. And that's it.
Thank you. Thank you so much. I don't know if we have questions. As usual, you will be available around, so people can reach you. There is one raised hand.
Okay, so you mentioned that it works, for example, with Volkswagen, but we are hearing about V2X and V2V and other stuff for past 15 years. I never seen real use of that. So what do you think, what is the future for all these V2 whatever technologies?
I think that there are two perspectives, right? You could have that perspective that Tesla use. Okay, you have the sensors in the car, you sense everything, you don't need to connect with other vehicles and other devices. I think that the V2X part will complement that. I think that the main problem is that we in Europe defend one standard, the guys in America defend another standard, and I think that this is the main part. And after that you have in the 5G, some kind of specification for V2X, and you have this specification for Wi-Fi. Okay, this one from Wi-Fi is easy to work for us as research. The other one from 5G is more difficult to work. But for instance, Volkswagen implement the Wi-Fi one. Okay, I think that in the future we will have that. I don't know which level we'll have, but I think that we will have that. Okay.
Okay, thank you.